Okay, so let's go over this one. So first thing I do when I have a limit is I plug in. So I'm going to get 6 minus 6, 0, 4 minus 4, 0. So it automatically tells me what?
Factor.
More work. I need to factor and cancel. So 3 times x minus 2 over x plus 2 times x minus 2. Does that look right? Cancels. That tells you that if you were graphing this rational function, that x equals 2 is not a vertical asymptote, it's a hole. But what do I have from this one? I'm going to end up with 3 over x plus 2. Vertical asymptote at x equals negative 2. So just remember, when you have rational functions, everywhere the denominator is 0 is not in the domain, but it could be a hole if it cancels. If it doesn't cancel, it's a vertical asymptote. Okay, so now I'm just going to plug in again. So 3/4. That's the answer to my limit. So now let's look at what it means. This means that the limit, there's going to be, in this case it's a hole because it canceled. The hole will be at x equals 2 and the corresponding y value. The corresponding y value is the limit of where that function is going, what the value would be if it were defined. So this would be 3/4. So let's go ahead and graph this just briefly. What is the base function for this? 3 over x plus 2. What's the base function? If you didn't have all the pluses and multiplies, and it would just be 1 over x. That's the base function. So what does 1 over x look like? Right? This one, x plus 2,
Goes to the left.
shifts to the left by 2, or we know that it has a vertical asymptote at negative 2. So either way, that's going to put that over here. And then 3 is just going to make it grow kind of faster. So I don't usually worry too much about graphing that. Okay, so when x is equal to 2, y is equal to 3/4, so there's actually not a point there. That's where the hole is. So that's what the graph would look like. So this looks like a much more complicated graph. In reality, it distills down to this, which is a pretty easy graph, and then it's just missing a 1 point. So that's how these connect. All right, let's look at,
What would be the scenario if you asked, like, the limit of that? Because you know how you could still ask it would.
the limit of this.
Yes, but by using that graph with the
Oh, yes, so let's look at doing it graphically. So let's say I didn't present you that, I presented you this. This is great. So we're going to get to the asymptote next time, so I'm not going to deal with that. But let's say I looked at this graph and I said, find the limit as x approaches 2 of this function. And so let's say I didn't know what it was. I just was presented with this graph. I'm going to find x equals 2. If you want to, you can do that. Just know that that's not a vertical asymptote. Now follow the graph until you get to the dotted line. So I'm following the graph. Do I need to worry out here? I'm pretty far away, right? Go ahead and start close to the line. So start here, and start here. So where, from the graph, I'm saying, well, as we get close to 2, that equals 3/4. Because I would give that to you. You wouldn't have to guess that. So this, I would say, is equal to 3/4. In this case, what is f of 2? Does not exist. F of 2 is not defined. There's no point there. So, so sometimes your limit equals your point, and sometimes there's no point there, or sometimes the point is totally somewhere else. So, yeah, so we can do it graphically as well. Yeah, so graphically, the main thing is just to, if it helps you, like I said, if it helps you to think or draw in a line and just approach it. As soon as you get to that x value, check out what your y value is, and that's what your limit will be. So the answer to a limit is always a y value. Okay, let's do one more piece that we're going to start introducing an important limit. So this is an important limit. We started to form the difference quotient for an assignment. So we're going to look at the limit of the difference quotient. So we have formed a limit quotient before, f of x plus h minus f of x all over h. You guys remember doing that? That was in one of the assignments. So what does this mean? Let's think about where this comes from, because it doesn't come from nowhere. How h, and so let me finish it. So we're going to look at this limit as h approaches 0. So h is a small number. So we've got this x value, and we've got another x value that's close but a little bit different. Does that make sense? So I've got a y value that goes with this x value, and I've got a y value that goes with that other x value. So that sounds to me kind of like change in y. Would you agree that's true? Change in two different y values? If one of the x values is x plus h, and the other x value is x, let's think about this. What is x plus h minus x? One x value minus the other. H. H. So really, this thing represents a change in y over a change in x. What does that sound like to you? So that's where we're going to get to in a little bit. So what I want you to practice this time is, so this is kind of where we're going in about 2 weeks. So what I'd like to do today is pull back from this a little bit, and I would like for you to look at this one. Same h going to 0, but now instead of x, we're going to have a very specific value. We're going to put in a very specific c value. But it's the same format for putting this together. And so for this example, we'll use f of x equals x squared, and c will equal 3. So let's look at how we're going to put this together. This is a case where if you can, some people are ready to just write out the fraction as it stands right now. Other people need to form this part separately and then this part and subtract. And so we'll go through all the steps, but you don't have to go through all those steps. If you're in a place, if you're comfortable enough, you can do it kind of correctly from the beginning. So let's come over here and start writing that out. So I'm trying to form this. So the first thing I need to find is f of c plus h. C is 3, so I'm really trying to find f of 3 plus h, and I know what f is. F is x squared. So I'm trying to find f of 3 plus h, and f is x squared. That says take the 3 plus h and put it in everywhere I used to have an x. So that means I'm going to take that 3 plus h, and what will I do to it?
Square.
I'm going to square it. I'm not tacking on the plus h at the end. This is an input, so it goes in the input everywhere there was an x. So this would be 3 plus h squared. We need to multiply that out. You can put them side by side to do FOIL. The other thing is you can remember what a perfect square pattern is. You square the first one, 3 squared is 9. You multiply these two, 3h, and then double that. So it's 6h, and then square the last one. If you don't remember that, you can put them side by side and just FOIL them out. You'll get the same thing. Okay, now I need f of c. In this problem, that means f of 3. So f of 3. What's f of 3? If I put it into x squared?
9.
Just 9. Right. Okay, so now I need to put together that whole numerator. So I've got f of 3 plus h minus f of 3. I'm going to put it all together. So 9 plus 6h plus h squared minus, go ahead and put everything else. This is simpler than it often is. It kind of as we get later. So I don't mind if you kind of keep that in parentheses just as a good habit to form. Does this simplify it all? Yeah, the 9's cancel. And then just because we tend to write things in descending order, I'm going to flip the order and put the h squared first. So all I'm doing here is canceling the 9's and then just kind of writing it in our normal descending order. Okay, so how far have I gotten? I've gotten the numerator. Now I need to divide by h. So f of 3 plus h minus f of 3 all over h is going to be this divided by h. So h squared plus 6h divided by h.
H plus 6.
Yes, yes. Any questions I can answer?
Doesn't that simplify down to h plus 6?
Yes, it does. So there are a couple ways to look at this one. You can
Pull it out.
factor out an h. This is sort of the where it comes from answer. I can factor an h out of the numerator. Can I cancel these two h's? Yes, they are multiplied factors. So we get h plus 6. Can I cancel this h and this h squared by themselves? No, because there's a plus sign. They're not multiplied factors. But if there's an h in every single term, that means I could have factored an h out. So you don't have to write this step if you see your way to saying there's an h in everything, cancel an h out of everything, and I'll get h plus 6. Just remember that if this did not have the 6 in front of it, it would give you h plus 1. A lot of times people just say h plus 0. That's not true. When you factor out an h out of a h, you get 1, factor of 1. You're not subtracting, you're dividing. Okay, so now we're here. So what are we trying to do? We've gotten this whole piece, now we just need to let h go to 0. So let's add that last piece. So the limit as h goes to 0 of this whole thing,
6.
yeah. What's the first thing you do with the limit?
Plug it.
Plug it in. Plug in 0 for h, you get
6.
This is a long process we're going to do in section 2.4 with other different functions. Okay? And we're going to be leading into slope. Okay? So this difference quotient is going to end up being the slope. Okay, so, back up. What I would like to, any questions? So take home point about limits. First thing you always do, plug it in. If you get 0 over 0, what do you know? More work. Is it equal to 0? Maybe. Is it equal to infinity? Maybe. Is it equal to any number in between? Probably. So you don't know, so you have to do more work. And that more work is what for our class? Factor, cancel. And because you're factoring and canceling that term that you're canceling, that's the hole in the graph. That's the point that's coming out because it's not defined. Okay, so now let us look at the project. There's a project for this class. I have tweaked it since last semester, so I think this is going to be much better than last semester. So let's just